Hey, kiddos in period 4. Some of you had asked a question about numbers 1 and 2. They're formatted in a little bit strange way. A lot of you popped back into the big group chat and I talked about number 1. I've left this up, the solution to the first couple parts of number 1 up so you can see how that was solved. The big idea here is the total momentum of all of the objects interacting before a collision must be equal to the total momentum of those same objects immediately after the collision, right? And so the total momentum before and after any collision won't change. Okay. Eventually I'll post a video explaining this entire worksheet, probably halfway through the week. But I'm going to clarify what number 2 is asking in this video right now. So number 2 says Henrik and Alanya are halfway through their competitive ballroom dance performance when they stand straight next to each other, then quickly push off from one another. Assume the friction between their shoes and the floor is small enough to be ignored. In just 4/10 of a second, Alanya, who has a mass of 50 kilograms, attains a momentum of 150 kilograms times meters per second. Use this information to complete the prompts below. Okay, now this is weird. If you look down below, you've got capital MV and lowercase mv. And we need to figure out what the heck's going on, quite frankly. What we do know is that they're going to push off each other, and that pushing is going to take 4/10 of a second. Okay. Before they push, we are assuming that they are standing, right? And what does that mean about their motion? If before the push, at time 0, they are standing, that means their velocity is 0. What does that mean about their momentum? That means both of their momenta are 0. Okay, so let's differentiate between Henrik and Alanya. We are using capital MV and lowercase mv. Let's go ahead and make Henrik lowercase m and Alanya uppercase m. Okay, so uppercase mv will be Alanya and lowercase mv will be Henrik. Okay, so I'll just put an A for Alanya and an H for Henrik. Those are their momenta. We've already established that before the collision, the total momentum, before they push off on each other, their total momentum is 0. Okay. And we know, right, if we're going to be consistent with the law of conservation of momentum, the total momentum before the collision must actually equal the total momentum after the collision. So at any point here, the momentum of Alanya plus the momentum of Henrik must be equal to 0. What does that mean about their motion? When two people push off against each other, one person goes in one direction, maybe we'll call that the positive direction, and one person is going in the negative direction, right? The opposite direction. And if you have a positive and a negative momentum, they'll combine to be 0. Okay, so at any point during the time that Alanya and Henrik are pushing off against each other, their total momentum is 0. Okay, before they push off, neither of them has any momentum. Halfway during the push off, their total momentum needs to be equal to 0. So Alanya, let's say she's going in the positive direction, she'll have a total momentum of 75, and Henrik will have negative 75. That adds to 0. How did I come up with 75? Well, that's halfway through the push. The problem clearly states that at the end of the push, after 0.4 seconds, Alanya has a momentum of 150, right? And Henrik's then must be equal and opposite for the total momentum to combine to still be 0. So that means that halfway through the push, both Henrik and Alanya should have half of that 150 momentum. So 75 and negative 75. Okay. So what pattern should this be? If we're looking at total momentum versus time, how is the total momentum changing? The total momentum, P total, must be equal to 0, right? And that's not changing, so it'll be a horizontal line at 0. And then if Henrik only attained half the speed with the same momentum, estimate his mass. Okay, so the momentum of Henrik is negative 150. All right. And that is equal to his mass times his final velocity. Or velocity, I think we're calling this velocity after. Okay, so we know his momentum afterwards. We know that Alanya has a mass of 50 kilograms. Okay, and if Henrik has the same momentum as Alanya, but gets to half the speed, that means that his mass must be double hers for the total MV to still stay the same, right? That 2 and 1/2 will have to cancel out. Okay, so that's if we have speed, that means we have to double the mass for the momentum to stay the same. So his mass is double hers, so that would be 100 kilograms. All right, and then if Henrik's shoes had considerably more friction or traction than Alanya's, should this make your estimate of his mass higher or lower? Okay, so if there is more friction, right, then the estimate should be some of that friction would have taken away some of the speed, and so that would make it lower. All right. Okay, give that a shot. Let me know if you have any questions. Send me a chat on Google Chats through your email itself, or ask me to pop into your table group. Okay? See you guys later.